I hope you know that when I'm recording this video, it is Friday, spring break has started, it is after 3 o'clock. You do not deserve me. Let's see, what am I going to do? 3. You are asked to do these using what's called the circular approach. So hopefully you filled out all that and you have it to look at. So I'm going to find the radius. The radius is the square root of 5 squared plus, who cares about signs when you're squaring, root 11 squared. So that's going to give me a 25 plus an 11, which is going to give me a 36. So the radius is 6. Now the reason I found all that is because the cosecant of an angle is the radius over y. So I'm in business, man. There's y. 6 over that. Now the only issue with this thing is the radical in the bottom. So I got 6 over negative root 11. I'm just going to go ahead and say that's a negative thing. I'm going to multiply, sorry, let me do this first. I'm going to multiply by root 11 over root 11 to clear it out. That'll be a negative 6 root 11 over 11. Because that's how you clear radicals out of the denominator. You're also asked to find the cotangent of the angle, and the cotangent of the angle should be x over y, if I'm thinking right. So that's even easier. That's 5 over a negative root of 11. I'm going to clean that up the same way I did the last one. Multiply top and bottom by root 11. So I'll get negative 5 root 11 over 11. There's my two answers. It's pretty easy stuff. I'm not going to do any more of the circular approach. Down beneath this, we're supposed to use a triangular approach and reference angles. So, using the triangular approach. What I'm going to do is I'm just going to grid this thing out. And I'm going to draw a triangle. Plain and simple. To form this triangle, I would go back 3 and up a root of 6. I'd go left and up. That's what I would do. I would go left 3 units, and I would go up, which is not the hypotenuse, root 6. Now I want secant and tangent. At least one of those requires a hypotenuse. Secant is going to be the funny guy ha. So I need to know this hypotenuse. That's what I have to know. So I got to do a little Pythagorean theorem. I got to do a negative 3 all squared plus a root 6 squared being equal to c squared. And that's going to give me, I think, 15 if I'm thinking right. 9 and 6, yeah. So 15 is c squared, so c is root 15. Now I got my little hypotenuse. Now the deal with reference angles is this is theta. And this little guy is theta prime. He's what I use. I use theta prime. So the secant ratio is hypotenuse, which is root 15, over the adjacent side, negative 3. Now you would put the negative symbol either in front of the fraction or in the numerator. It doesn't really matter what you do. I usually put it in the numerator, but it's not supposed to be in the bottom. Sometimes they leave them in the bottom on Saturday's test to speed kids up, but it's supposed to be either in front or up top. Then you got tangent of theta. Well, you don't need much for that one. That's root 6 over negative 3, isn't it? And again, the negative symbol belongs in the numerator. So there's those two. 8 I'm going to leave for you. I'm going to do the one that's very similar to that one, which is on the back side, number 9. I did one of these in class, or at least I will do one of these in class on Monday when you get back. But angle F's terminal side intersects a circle with a radius 4 at negative 3, negative 7. So I am going to draw the original situation to help explain why these things don't work. There is a circle. It should say centered at the origin, but whatever. It has a radius of 4. And this angle rotates through the circle in such a manner that it intersects somewhere in quadrant 3. I almost went to quadrant 2. It intersects at negative 3, negative root 7. Now the little triangle that was made here, and I still am using triangular thinking here because I want to see it and I want to see the angle. I guess I don't have to, do I? I don't have to use a triangle. There's the original angle. It stops right there. I can use the circular approach to these. If I want the sine ratio, I would do y over r, be negative root 7 over 4. If I want the cosine ratio, I would do x over r, which is negative 3 over 4. And if I want the tangent ratio, I would do y over x, which is going to be negative root 7 over negative 3, which is root 7 over 3 because the negative symbols cancel. Now I'm asking you to go ahead and do the arc sine, arc cosine, arc tangent of these things to determine this angle's measure. Now, you know as well as I do that this thing exceeds 180 degrees, for sure. It exceeds 180 degrees. None of these are going to say that. None of them. This is going to return a negative angle. This is going to return a negative angle. This is going to return a negative angle. These are actually all going to return negative angles, every one of them. So let's see what the arc sine of a negative root 7 over 4 actually returns. I'm not going to be surprised by the results. You might be, because who would have thought that a calculator doesn't tell you the truth? It does. It does exactly what it's programmed to do. It is programmed to return an angle in quadrant 2 or 4, negative 41.41 degrees. How about the arc cosine of negative 3/4? It's also going to return, actually, this is going to return a positive angle. It's going to return a positive angle in quadrant 2. It's going to be more than 100 degrees, 138.59 degrees. Now I have arc tangent. This should return negative 41.4. Those two should be in complete agreement. This is one of the things that makes trigonometry a little bit more difficult. it returned positive. 41.41 degrees. Yeah, it was a positive ratio. None of those return the same thing. Isn't that crazy? None of them return the same thing, and none of them are even right, are they? None of them. What they all returned, with the exception of cosine, was a reference angle. Cosine doesn't return reference angles. It does unless it's a quadrant 1 angle. This guy gave me an angle that looks about like that. This guy gave me an angle that looks about like this. And this guy gave me an angle that looks like that. Now, what do they all have in common? This is 41.41 degrees of negative rotation. This is 41.41 degrees of positive rotation. And this little guy right here, if you take away the 138.59 from 180, and I'll prove it to you, you get 41.41 degrees. What they all returned was the separation between an x-axis and a terminal side. You had to manipulate cosine to see it, but they all returned that this was 41.41 degrees. Every one of them did, if you thought about cosine. So what is the actual measure of this angle? The actual measure of this angle is 180 plus 41.41 degrees, which is 221.41 degrees. Now, I can kind of prove this with you with technology. The sine of 221.41 degrees is going to be ridiculously close to negative root 7 over 4. I rounded to the 0.41, so it's not going to be exact. But here's the sine of 221.41, negative 0.06144. And this is what I should get back, negative root 7 over 4. Oops, typo. There we go. See how the decimals match? Rounding happened when I rounded the angle, but there it's out to the thousandth position before change happens. There's that. Let's see here. What am I willing to do down here on these New York Regents exams questions? Be glad you don't live in New York. You failed their EOC. You have to retake the EOC until you pass the class. That's the way New York is. I think they give you 2 or 3 chances to retake the test. But if you don't get credit for your class until you pass the test. Now, vice versa. A kid can do nothing all year, and if they pass their end of course test, they pass the class. So there's that. If the cosine of alpha is root 5 over 3 and the tangent of alpha is less than 0, what is the value of the sine of alpha? A lot of words there. Pretty tough problem for kids. I will be teaching you an acronym pretty soon, and it goes like this. All schools torture children. Or what? This says sine, cosecant, positive. All ratios, positive. Tangent, cotangent, positive. Cosine, secant, positive. So, I am told right here that the cosine of alpha is positive. Cosine, hold on a second, I gotta answer this call. Hey, give me just a second, I'm recording. Let me pause this. Alright, so where was I? Oh yeah, the acronym was what I was talking about. And I got interrupted, just like any other time I try to teach. This is positive. Cosine, by the way, which is x, think about that, cosine is x, is going to be positive here or here because this is where x is positive. So I'm going to circle that and I'm going to circle that. Tangent, which by the way is y over x, which kind of makes things different. It says less than 0. That means that the ratio is negative. Tangent is negative here and here. This angle lies in quadrant 4. I will be teaching this, and it's something kids struggle with, but it is what it is. So this is where I'm going to draw a triangle. Or I could do a circular approach, but I'm just going to draw a triangle. I'm just going to put it down here. Angle A actually rotates all this way, so I'm going to use A prime, the reference angle. Kind of, that looks more like Al, A prime. And I'm just going to fill out the ratio. Cosine is adjacent over hypotenuse. So adjacent is a root 5. The hypotenuse is 3. And I'll do a little Pythagorean theorem to figure out the missing side. A squared plus B squared is C squared, blah, blah, blah. So root 5 squared plus A squared is 3 squared. That's going to be 9. 9 minus 5 is 4. A squared is 4, so A is 2. Now, here's the issue. Direction. This imaginary triangle, and it's not really there, it's just to help you out, fell 2 units. Okay, so the sine of alpha, or sine of A here, would be opposite negative 2 over 3. Choice 3. Now, AST also tells you something. The only thing that's allowed to be positive in this quadrant is either cosine or secant. So by default, the answer is negative. Welcome to Trig. I'm also willing to do number 21 for you. A tree farm initially has 150 trees. Each year, 20% of the trees are cut down and 80 are planted. Which recursive formula models the number of trees A sub n after n years? So I'm going to kind of write this out a little bit. We have 150 trees to start with, and then something happens. We cut down 20% of them. If you're going to cut down 20% of something, there's going to be 80% of it left. So I'm going to take 150, I'm going to multiply it by 0.8, and then I add 80 back. There's 200 trees. The next year, the same thing happens. I cut down 20% of them, and I add 80 back. 240. This thing's actually going to grow slower and slower and slower until eventually it kind of levels out. It should level out. A little curious about this formula. 272. See how the growth is slowing? Now, why did I do that? Well, I did it because I can actually plug numbers in and see if these things make any sense. Like these two right here, these are garbage. It might work for the first one, it won't work for the second one, and they're garbage because they're not recursive. But I'm a little curious if they work. I have a suspicion that this one would work if you let n be 0. But past that, I don't think it would. Like if you take 150, 2.8, raise it to the third power, and add 80, you got 156.8. That's not in anything down here. But these are not recursive. A recursive formula will almost always use a sub n minus 1. Sometimes they use things like a sub n minus 2 and a sub n minus 3. It just depends on how far back you have to go. That would make a lot more sense if you guys did programming. Legit programming, not whatever they pass off as programming now. I can glance at this and tell you that the answer is 2. Because think about the math that I was doing. I was multiplying by 80% and then adding 80. And here is your first year, 150. To get the second year, I would take 150, I'd multiply it by 0.8, and I'd add 80, and by God, that's 200. So that's recursive trains of thoughts. They're fairly natural to most people. If you ever get into programming, computer science, you will do recursive thought patterns. But what do I know? Right? I hope you enjoy your break, or I hope you enjoyed your break.